Hello, good morning, everyone. Today, I want to give you an insight on how graphene nanotubes can help to develop and to produce multifunctional textile. My name is Fabio Tombolato, and I'm working in OCSiAl as a technical customer service manager. As a background, I have a PhD in physical chemistry, and I spent 14 years working as R&D and process engineer team leader in many different sectors. The most relevant are coated textile for industrial application, composite rollers and sleeves, paint and coating for industrial application. Together with me today, Hendrik Jansen. Hendrik is a material science specialist with a focus on nanotechnology, graphene, and single-wall carbon nanotubes. Hendrik is working in our product development department and is based in our laboratory in Luxembourg. Before going to the topic of the webinar, a few words about OCSiAl. OCSiAl is the world's largest producer of single-wall carbon nanotubes, with the only scalable technology that makes this material available at industrial scale. We are represented globally in more than 50 countries, and with a team of more than 100 people in R&D and technical department, we can support our customer in each phase of the product development, since the very beginning R&D activities up to the industrial test and industrialization phase. Furthermore, our specialists can develop customized solutions in collaboration with our customers. OCSiAl is a truly global organization with more than 550 employees and a distributed network of production sites, R&D and technical centers, dealers, and sales force offices. This is the summary of today's webinar. I will give you a brief introduction of what graphene nanotubes are and which kind of properties they can bring to the material with a focus on textile. In the last part, I will share with you some interesting business cases. Graphene nanotubes, they are also called single-wall carbon nanotubes, are namely made by a single sheet of graphene that is rolled up to form a very long, more than 5 microns, and very thin, less than 2 nanometer, flexible tube. Flexibility, together with a very high aspect ratio, together with a wall thickness of only 1 atom, give to this material peculiar properties. Graphene nanotubes were discovered in the early 90s, and they are known as material with unique properties compared from all the other materials that are on the Earth. Graphene nanotubes are excellent thermal and electrical conductor. They are 100 times stronger than steel. Just to give you an idea, the tensile strength of this material are in the range of terapascal. Graphene nanotubes are ultralight material. 1 gram of stretched graphene can cover twice the distance between the Earth and the Sun. Eco-friendliness and sustainability are 2 important points that need to be taken into consideration when developing a new product or a new process. And here you see some benefits that you can achieve using tubal graphene nanotubes. Increased functionality using less. Graphene nanotubes are so effective in bringing properties to the material that a very low working dosage is needed to achieve the target. Clean production without dust. OCSiAl has developed a full range of master batches and solution concentrate that help the customer to manage graphene nanotubes in a very clean production without dust. Low working dosage, high efficiency, clean production thanks to the use of master batches, and a very efficient logistic all contribute to reduce the emission accounted for the product process production. Graphene nanotubes can bring properties to the material, and these properties will be stable. Namely, they will stay for the entire life of the material, and this strongly contributes to extend the durability of the final product. And now let's focus a little bit on textiles. Multifunctional textile, they can be woven or non-woven system, are engineered textile that are modified to give them peculiar properties. These properties are fundamental for the application of the textile itself. There are different strategies that can be used to functionalize textile. An existing fabric or yarn can be treated with a coating that bring the properties, or the yarn itself can be modified during the spinning process. Graphene nanotubes are so versatile material that can be used in all these kind of approaches, alone or in combination one to the other, to bring to the textile different properties like ESD protection, together with thermal transport, together with dust repellency and touchscreen compatibility. Tubal nanotubes can bring multiple benefits for textile. Wide range of resistivity it is possible to achieve thanks to the high efficiency of this material. The very low working dosage, we are seeing that starting from 0.02% of graphene inside the system are enough to achieve the final properties, give to the customer high flexibility in terms of the formulation. The very low working dosage is fundamental to balance, to maintain, or to even enhance all the other properties of the material that are important too, like mechanical properties and chemical resistance. The use of master batches help the customer to manage graphene nanotubes in a very clean production and with a very efficient logistics. And furthermore, the use of master batches help the dispersion process using standard industrial equipment. Color is an added value that can be reached using graphene nanotubes. As you can see from the table, the very low working dosage of graphene nanotubes as a function of the target volume resistivity led the possibility to develop colored products that bring together electrical conductivity and aesthetic performances. Graphene nanotubes led the possibility to develop ESD protective textile that are compliant with international regulation like EN ISO, ESD, and ATEX, but maintaining all the other properties of the material unchanged, like mechanical resistance or chemical resistance. To achieve property from graphene nanotubes, it is important to understand the mechanism that is behind. Graphene nanotubes bring electrical and thermal conductivity and can improve the mechanical properties thanks to the 3D network that they can build inside the polymer matrix. And to build this 3D network of nanowires, dispersion plays a crucial role. As OCSiAl, we have developed tubal concentrate and master batches that help the dispersion of graphene nanotubes. Furthermore, we can supply the customer, we can help the customer to define the better condition to achieve a good dispersion using the standard mixing equipment. And then we can support the customer supplying all the technical guidelines to control the quality of the dispersion at the laboratory level. In this slide, we summarize the grades that are more suitable for textile application. As you can see, they can cover different systems and different chemistries. We have grades for polyurethane chemistry, we have grades for epoxy chemistry, for silicone, we have grades for thermoplastic polyurethane, for thermoplastic in general, and PVC plastisol. Matrix concentrate differ one to the other by the quantity of the graphene nanotubes that are inside, but also the carrier that is used to prepare the concentrate, and it is specifically designed according to the target chemistry system. We have dispersing system like plasticizer, like reactive dilutant, or even polymers. For water-based suspension, graphene nanotubes are stabilized in water using anionic surfactants. In this part of the webinar, I will share some interesting business cases. I mean, how our customers were able to functionalize textile using graphene nanotubes. It is important to remind that tubal graphene nanotubes are authorized for use in a wide range of industries, and they are the only single-wall carbon nanotubes that completed the registration at European reach. Tubal graphene nanotubes are also allowed in the US market, and they are authorized by EPA agency without any limitation in terms of volumes. ESD protection and anti-dust properties can be achieved combining the chemistry of polyurethane together with our tubal matrix. Here you see two examples. Application: hospital bed covering for clean rooms. Synthetic PU system was modified with matrix 202 to achieve anti-dust properties and anti-static properties, maintaining the chemical resistance of the material unchanged. Just to give you an idea, in this specific case, a volume resistivity, a surface resistivity in the range of 10 to 6, 10 to 8 was achieved. Water-based polyurethane solution can be also obtained using our tubal coat E application for car seats. The properties that were achieved are anti-dust performances together with anti-static properties, maintaining the mechanical properties of the coating unchanged. ESD protective wear can be obtained combining the chemistry of silicone together with our matrix 601. Anti-static properties that are compliant with international standard for protective wear can be achieved. What it is important is that graphene nanotubes can bring an additional properties. I mean, no carbon release on the surface. Graphene nanotubes strongly interact with the polymer matrix, so they will not migrate on the surface, like, for example, carbon black. ESD protective wear can be achieved combining the chemistry of PVC plastisol together with our matrix 814 to achieve antistatic properties together with mechanical properties. This is a clear example of what a multifunctional fabric is. I mean, a system that brings together different properties. In this specific case, ESD protective properties were combined to chemical protective properties, combining the chemistry of FKM together with matrix 608 and 622 beta to achieve antistatic properties that are compliant with the international standard for protective wear. Fireproof antistatic clothing for protection against spark can be obtained using, for example, our tubal latex to achieve antistatic properties. As I told you before, graphene nanotubes bring properties that are stable over time and over the entire life of the material. And in this specific case, the antistatic properties were maintained also after 15 cycles of washing. Different application, touchscreen compatibility, ESD protective touchscreen PU gloves can be achieved combining the chemistry of polyurethane together with our tubal latex to achieve touchscreen functionality and ESD properties that are compliant with EN 16350. Different application, interactive electronic gloves with touchscreen functionality. In this specific case, the yarn itself were modified to achieve the electrical properties. Polyamide filaments were covered with thermoplastic polyurethane made conductive using tubal matrix 808 to achieve touchscreen functionality, but maintaining the mechanical and the chemical resistance of the material. Industrial gloves for ATEX area can be achieved using the chemistry of MBR together with our tubal latex. Antistatic properties can be achieved compliant with EN 16350. Different application, heating film for roofing anti-icing can be achieved modifying the yarn, in this specific case polypropylene and polyamide, with our matrix 808 to achieve heat transport. Up to now, I show you example of woven textile, but also no-woven textile are possible. Application like cloth and insole, ESD no-woven textile modified with water-based thermoset system are possible, and it is possible to achieve permanent ESD protection. Electrical conductivity and ESD properties are not the only one that can be achieved using graphene nanotubes. In this slide, we put the most relevant and the most promising one that are under the investigation of the scientific community. In many cases, the investigation is still at the very early stage, but nevertheless, it is important to mention in this webinar, just to give you a complete picture of the potentiality that is behind the use of graphene nanotubes. So let's focus on some of them. As I already discussed with you about the possibility to improve the mechanical strength of the material using graphene nanotubes. But graphene nanotubes can also improve the UV stability of the material. For sure, they can improve the durability and the washability of the material. A very interesting property that graphene nanotubes can bring is the water repellency, thanks to the 3D structure that they can build on the surface of the yarn or the fabric. And thanks to the very high conductivity, also EMI shielding functionality, it is possible. Business cases that I share with you today, together with many more, together with other technical information, can be achieved in our website, tubal.com, or you can find information in our YouTube channel. For any kind of question that will arise, please write an email at webinar@OCSiAl.com. Thank you very much for your attention.